Hey everyone, let's solve longest increasing subsequence, which is a DP problem from Leetcode. So let's look at the question. We're given an array nums and we had to find the length of the longest strictly increasing subsequence. So let's try to understand the question first. So here we have the numbers, one of the examples, 10, 9, 2, and so on. So a longest increasing subsequence. So subsequence is anything. If suppose we have a sequence A, B, C, D, E, F, and so on, then a subsequence is A, B, C, or it can be A, B, D, or it can be B, D, F. But C, A, B, for example, would not be a subsequence. So basically here the order matters. So if you look at this array, after 10, we have 101, which is greater than 10. So one of the possible subsequence will be 10, 101. And they're saying that all subsequence should be increasing, strictly increasing. That means that if suppose I have the I minus 1th element and I have the ith element, then the ith element should be strictly greater than the I minus 1th element. So that's what it means by strictly increasing. So if we take 10, then we can form 10, 101. We can form 10, 18. That's possible. 10, 9 is a subsequence, but it's not an increasing subsequence. So here, what they're asking us to do is to return the length of the longest increasing subsequence. So you can see why sorting would not matter, because in that case, it would not be a subsequence. So how do we get it? Okay, if we just look at this example, then we can select that if we choose 2, then 3, 7, and either 101 or 18, then we get the longest increasing subsequence for this. 2, 3, 7, and 101. This is of length 4. So we would return that as our answer. So the brute force approach to solve this problem, that is, we'll discuss the recursive solution in this video, is for every element that in the array, we consider whether we have to include it in the sequence or not. For example, let's check with the same array, and then, we're looking at the 10th element 10, right? Now we have two choices. We want to include it or we don't want to include it. If we include 10, then we go to the next element. Here we can include 9 or we cannot include 9. So here again, we're looking at 9. So we include it or we don't include it. But we can only include a particular number if that number is greater than the previous number, right? That's the condition for it to be increasing. So here, after including 10, we cannot include 9. So then if we go to the next number 2, we cannot include it. 5, 3, 7, 101, finally. So we can include 101 because 101 is greater than 10. So here we have 101. And we can include it. And so far our length is 2 because we have 2 elements in the subsequence, this particular subsequence. In this branch of the tree, there's 2 elements. So if we do not include 101, then we again go further from 101, we go to 18. Yeah, we can include 18 because 18 is greater than 10. Then we again have 2 choices, we include or not include. So if we do include 18, then here we included 10. We did not include 101, we included 18, and the length is again 2, right? So if we keep going like this for every element, now again, we do not include 10. Now we consider that we are including 9. Then we cannot include 2, 5, 3, 7, but we can include 101. So again, you can just see that after you include 9 in your subsequence, you either include 101 or 18, and again, you'll just get a length of 2. So now you do not include 9 as well. And then you have two choices for 2. Include 2, do not include 2. If you include 2, then you can include 5. So here's the catch. So if we include 2, then we include 5, we can include 7, and we can include 101. Again, the answer is 4 from here. So there can be multiple solutions, but what they're asking us is we have to just return the longest one. So the recursive solution for this is the same. For every element in the array, we have two choices. It's whether we include or don't include. And we only include it on the condition that the new element that we're adding to the subsequence is strictly greater than the previous element that was in the subsequence. So once you get this concept, the code is simple. So let's look at the code. So this is a function which we're supposed to write the code for. I'm declaring n as length of nums. M is the minimum of nums. And I'm calling another function, a helper function, f. There could be a better name, I know. And I'm passing it the array. I'm passing it 0. This 0 represents the index of the element in the array that we're visiting. And I'm passing it m minus 1. This is nothing but the basically the previous element that was added to the subsequence. If you remember, the condition that whether we add the new element to the subsequence or not depends on whether the new element is greater than the previous element. So we need to be able to pass the previous element. We need to be able to access it. And so I'm passing it as a parameter. And I'm passing it the minimum element minus 1. It's just like a local maxima. If you're using Java or C, you can like set it to negative infinity. I mean, negative infinity as a negative storage limit, whatever int can handle, right? So, and then we're passing it the length. So in the helper function, this is the recursive function over here. Then first of all, we check if the index that we're at is part of the array. If not, then we're just returning 0. So keep in mind that, throughout this recursive function, we're keeping track of the length of the current subsequence, right? Now, the condition to add is if the nums of I, the element that we're at right now in the array, is greater than the previous element of the subsequence. If it is, then we have two possibilities. Either we include that element in the subsequence or we do not. So there is no guarantee that including nums of I will give us a solution. So that's why we need to consider both the possibilities and then just take the possibility that gives us the maximum length. So in case this condition fails, then we only have one possibility, is that we do not include this element at all. So that's simple. So here I'm taking max of 1 plus. 1 plus as in 1 plus indicates that we are considering the nums of I, the current element right now. And then I'm calling the function again with passing it nums and I plus 1. That means it means that we're moving on to the next element. And here the previous is changing. It's becoming nums of I. That means that this is the latest element that was added to the subsequence and n. Here, again, we pass it nums of nums, and we're going to the next element I plus 1. The previous here remains the same because here we're not considering the current element. We're not adding it to our subsequence. So that's it. This is the code. But this is just a recursive solution. If you run it, you'll get a TLE, as you can see over here. So this solution can actually be solved using dynamic programming. We'll see how in my next video. Thank you for watching.